Thanks for coming. I'm Francisco Tiziot, developer advocate at Ivan, and today I will talk to you about event-driven applications with Apache Kafka and Python. You may ask yourself why I'm at the Global Azure talking about open source Apache Kafka and Python. Well, we will see that later. First of all, thank you to all the sponsors collaborating with to all the sponsors collaborating with Global Azure. And now let's try to understand why at Global Azure, or why you should be interested in Apache Kafka. Well, I believe if you are at this conference, you will be somehow interested in developing some sort of application. And you will be in kind of either one or the other case. The first one being you are developing a new shiny app. It's your idea, you just started developing it, and you just started implementing all of it. The other option is that you inherited an old rusty application, and you have to maintain it, to extend it, and maybe to take it to the new world of applications. Maybe this old app was built like 10, 15, 20 years ago, and you need to port it to the world where we live now. No matter old or new, I've never seen in my life a single application working in complete isolation. We will have within the application components that need to talk with each other. So component A of the application needs to talk with component B. Or if we expose this application out in the world, this application will need to talk with other applications. So I will have the new application talking with the old one, talking with another one. Well, let me tell you a secret. Apache Kafka is a tool that makes this communication really, really easy. If we go back a few years, we had the design principle that was stating that we have an application. In this case, it's Python. I'm talking about Python because it's really widely adopted. So you will have an application, and the old design was that this application was writing the data to a backend database or reading the data from this backend database. No matter what, if reading or writing, this wasn't done for every single line, every single new item, every single event that this app was producing. Most of the times, the app was producing a set of events and then creating a batch and pushing that batch in the database, or reading from the database in batch and then having to wait a batch time before the next time it was reading. This batch time could be seconds, milliseconds, minutes, hour, depending on your implementation. But still, it was adding a constant delay between when the information was ready to be pushed from the application and when it landed to the database, or when the information was available in the database and when it was pushed back to the application. On the other side, we live in a world now where everything is immediate. We cannot wait batch time anymore. We live in a world where we have event-driven applications. What are event-driven applications? Applications that react immediately after an event is generated. So the event happens, and I need my application to know about the event, to start parsing the information of the event, and to probably start pushing the outcome of the processing to other event-driven applications to form a chain of this kind of parsing and managing of those events. So we understood that we are in a world like that is fast, that is event related, but what is in reality an event? An event, we all know events, and we all are familiar with, for example, notifications in our phones. The notification is the manifestation that an event has happened. I receive a message, I made a payment with my credit card, someone else has stolen my credit card details and is making payments. As you might guess, I want to know about the thief immediately so I can react on it. I can immediately call my bank to stop my credit card, and I need to do it now. I cannot wait 5 minutes, 5 hours, 2 hours, 3 minutes. Every minute lost is me losing money. But even before going to the digital world, we were used to events and notification. Just think about, for example, the alarm that was beeping every morning. that was triggering a set of actions, and we were basically reacting as event-driven application because we were either waking up or snoozing the alarm, but still we were doing something after we were receiving the notification about the event. But we are not only passively receiving events, we can also create events. Just take, for example, with the same alarm idea, the moment when you change the alarm, that is an event that will change the shape of the future, that will change the shape of your actions in the future. And going back to the digital world, especially in these days of pandemic, we are all being used mobile phones and mobile phones to make food orders. And if you think about opening the app, going to the food order application, ordering some food, selecting the restaurant, selecting which food items you want, all these are events. And once you pick the order and you send the order to application, that is generating a chain of events, sending the event to the restaurants that you have chosen. And this restaurant will act on it and will prepare the food for you, and then will generate another event for the delivery person to come and pick the order. And if you order pizza, well, that is another event. The pizza is ready. Delivery person, come here and pick the order. So why understanding events is critical, and why is it critical doing it in real time? Well, because the information has value as long as it is closer to when the event happens. Just think about the pizza. If I have a delivery of the pizza, I want to know exactly where the pizza delivery person is. I couldn't care less about the position of the delivery person 5 minutes ago. The information has value only from the time that it is taken from the mobile phone of the person doing the delivery till the time that it reaches the map of my phone. I have a delay of 10 seconds, 20 seconds, 30 seconds. After that, the information is not more relevant. So what is Kafka? I told you before that is a tool that makes this communication and this kind of real-time application with this real-time messaging really easy. But the basic of Kafka is just a very, very simple idea. It's the idea of a log. A log where we store those events as messages. So event number 0 happened and we store it. Then it comes event number 1, 2, 3, and 4. The beauty of Kafka, and one of his strengths, is that it's append only, and immutable. So this means that once I write event 0 there, I cannot change it anymore. It's not like a database that I can go back and, okay, now event 0 contains 2 pizzas instead of 1. No, if something changes the reality of event 0, I will need to store it as a new entry in my log. And even more, the information, the message regarding the event is persisted on disk, is not only available in memory. This makes also Kafka more durable in case of failures. It would be said if all Kafka was a huge tool to manage a single log of events. We all know that events happen in life and there are multiple types of events. So for example, I could have pizza orders and I could have the delivery position type of events. And Kafka allows me to store different types of events really easily. And in Kafka terms, those different logs are called topics. So I have topic A for the pizza orders and topic B for the delivery position. Even more, Kafka by nature doesn't require a huge single server. It's a distributed system. So this means that when you create an instance of Kafka, actually what you create most of the time under the covers is a cluster of nodes, in this case, 3 nodes. In Kafka terms, those are called brokers. And the log information is not stored only once across all the brokers, it's stored multiple times. As you can see here, have the same log sharp edges and round edges copied multiple times across the various brokers. And if you see the 2 logs are copied on a different number of times. So the sharp edges topic is copied 3 times, the round edges topic is copied 2 times. This is driven by a configuration that I can tell Kafka by topic that is called replication factor. The replication factor dictates how many copies of a certain log I have in my cluster. So in this case, it's 3 for sharp edges and it's 2 for round edges. Why having replicas of the log is a good idea? Well, just think about if we lose one node. What happens here? We don't lose data. The data is still there, still available. I still have a copy of sharp edges and round edges log. Let's go a little bit more in deep into this example. Let's try to understand what Kafka does. So let's go down to our 3-node cluster and let's just check for one single log, the sharp edges log. Now let's assume that this log has a replication factor of 2, and now we lose one node. What happens? Well, Kafka will somehow understand that one node is not accessible anymore. It will check what are the logs around, and it will see that the sharp edges log is available with only one copy, but a replication factor of 2. So what Kafka will do is will start copying over the log to another broker within the cluster which is available to keep the number of copies in pair with the replication factor. So now what happens even if we lose a second node, we still have our log data available. Okay, we understood what Kafka is and how Kafka manages, and how Kafka is basically really high available and fault tolerant platform. But what is an event? How is an event represented in Kafka? Well, let me tell you a clear story. Kafka really doesn't care. All Kafka cares about is a key and a value. And within that key and value, Kafka only cares about it being just a series of bytes. It doesn't impose you any data format, anything. For Kafka, you just have a key and a value, and those are just bytes. You can go from really easy messages in Kafka, which, for example, is I want to store the maximum temperature as key, and the value is 35.3. Or I can go even really complex. I can, for example, going back to this pizza idea, I can store the shop receiving the order and the phone line used to make the order. And as value, I can store the order ID, the name of the person calling, the phone number of the person calling, and all the list of pizzas within the order. Kafka doesn't really care. And also how you store information, you could use JSON like in this case. But JSON is not optimal because it includes for every field, the field name and the field value. So what you can do, you can use more compacted data types, for example, Avro. Avro allows you to specify kind of the same information that you have in the JSON format, but since it detaches the schema from the value itself, you have a much more compacted way of transmitting the same information at a cost of having a tool called schema registry that allows you to basically crunch the data in a smaller package. And when you receive the data, you take the schema from the schema registry and you are able to disassemble the package itself and read the data properly. So now we understood how Kafka wants a message to be. It's time to understand how you interact with Kafka. The first thing that we want to do is actually write to Kafka. So we will have our Python application that if wants to write to Kafka is called a producer. And usually it writes to a Kafka topic. It can write to multiple Kafka topics. In our case, it's simple, just one Kafka topic. All it needs to know to write to the Kafka topic is where to find Kafka, so the list of brokers as host name and ports, how to authenticate to Kafka. So do you want SSL authentication? Do you want SASL authentication? Do you want no authentication at all? Well, I wouldn't suggest that, but it's an option. And then the third thing that the producer needs to know is how to go from the, for example, JSON format to the raw series of bytes. So how to encode the data. On the other side, we will have the data in Kafka and the process, in this case Python, that wants to read the data from Kafka. And is called consumer. How this works is that the consumer will read the message number 0 and then communicate, hey Kafka, I read number 0, let's move to number 1. It will read the number 1 and go to number 2 to number 3. Why this is useful? Well, because if there is a failure on the consumer side, still Kafka knows until what point the certain log has been read. So the next time that the consumer pops up, it knows from where he has to start sending messages again in order to not to resend the same message twice. All the consumer has to know in order to read data from Kafka is, again, where to find Kafka, how to authenticate, same as the producer. And since before we were encoding, for example, from JSON to raw series of bytes, now we need to understand how to decode from raw series of bytes to JSON. And last information is which topic or which topics do I want to read from? Because I could read from a list of topics. Now I believe you are already bored after basically 20 minutes of me talking on slides, and it's time to do a demo. And since we are, I believe, a lot of Italians here, I will do a pizza-based demo. So let's move to Firefox in this case. And as you can see, this is the console. So this is Ivan, the company that I work for. We are providing open source managed data structure in a lot of clouds, including Azure. So what I did before joining this talk is I created 2 instances, one of Kafka and one that we will see later of Postgres. The beauty of it is that you can either create yourself, and if you want to select Kafka or any of the other open source data platforms, what we offer is the managed service across a lot of clouds, including Azure. So you can select Azure, select the region within Azure that you want to use, and the plan which is driving the amount of resources and the associated billing. This is the total cost that you pay per month for a business Kafka service. I pre-created them for the instances for us. It usually takes only a couple of minutes for the instance to be up and running. How did I create them? Well, I have a series of notebooks that we will go through during this session that allow me to create everything by code. In this case, it's all bash code using the Ivan client. And later on, we will use Python to start interacting with Kafka. So first of all, we want to produce data to Kafka. Let's open the producer. So we have a producer. We need to install the Kafka Python, which is the default library that you use to interact with Kafka. Once this is installed, there we are. We can create a producer. As I said before, all you need to know is where to find the Kafka, how to connect using SSL and those 3 certificates, and how to encode the data, how to serialize the data. So from JSON to raw series of bytes. I create a producer. It's done. And now I can start pushing data to Kafka. Well, let's push one record with key id1 and name Francesco, myself, ordering a pizza margherita. OK, this is done. The data is in Kafka now. How can I be sure that the data is in Kafka? Well, let me start a consumer. Let me put it on the right, and let me close this for a bit. Again, we are creating a consumer. Let's leave out for now the group ID. We will come back to this later. I'm creating a consumer. I call it client1. This string can be anything, part of a group. I need to know where to find Kafka, the same SSL settings as before. And now, since before I was serializing, now I need to deserialize. I create the consumer. Now that the consumer is created, I can check which topics are available in Kafka. And I can see a lot of internal topics, but also a Francesco Pizza topic that I just created for this purpose. So I register to the Francesco Pizza topic, and now I want to start reading from it. So I start reading from it, and you can immediately start seeing 2 things. The first one is that this kind of piece of code never ends running. This is because it always checks with Kafka, is there a new message, a new set of messages for me? No, I wait and then recheck, recheck, recheck. The other bit that it might be interesting is that we push one order here, but we don't see the order on the consumer side. Why is that? Well, it's because the consumer by default starts reading from Kafka from the point in time when it attaches to Kafka. This is the default behavior. Later on, we will change this, but as of now, we will not read the order number one because we attach to Kafka later. But still, to show you that everything is working, let me push 2 new orders. I know that a lot of people will like ban me from Italy because I'm ordering for Adele a pizza Hawaii with pineapple, and for Mark a pizza with chocolate. So stay with me, don't go away. Let's check out. Okay, we sent on the producer side on the left order for Adele and an order for Mark, and we immediately received them on the consumer side. So the whole pipeline is working. We understood how to produce data and how to consume. Let's go back now a little bit on the slides. Okay, so produce and consume, all good. Let's go back to understanding Kafka. So we said that the log is contained in a broker. And we said that Kafka doesn't require huge servers because it's distributed. But if the whole log has to be stored in a broker, this means that I need to size the broker depending on how big I think the log can be. On the other side, I can only store messages until the log raises the size of the disk in the smallest broker in the cluster. Well, I don't want to have this trade-off, and Kafka doesn't force me to do this trade-off because it allows me to define within a topic what are called partitions. Partitions is a logical way to distribute events of the same time. Let's think about pizza orders, depending on a classification that I want to give. So, for example, I have my pizza orders, and those are all events of the same topic, of the same type. I want to store them together, but maybe I can store them in different partitions based on the restaurant that is receiving the order. So, for example, I have blue events, blue orders for Mario's Pizza, yellow events for Luigi's Pizza, and red events for Francesco Pizza. This makes sense because they are still all events of the same time, and I probably want all the events of the same restaurant to be one next to the other. And we will see more about this later. If now we understand that we can take events of the same topic and split it in different partitions, let's go back to check our 3-node cluster. This is our 3-node cluster, and what you will see now is that I don't have to store the whole log in one broker. I can just basically size the broker for the size of a partition, because the partition is what is going to be stored in a broker. This makes the discussion and the trade-off between log size and brokers and disk space in the broker a lot easier, because if I have a log which I know will contain a huge amount of messages, well, I need only more partitions to fit them in a smaller disk. And just check now, even if now we lose again another node, well, we have still all the partitions for all the data about all the partitions still available. We said earlier that once you push the data to Kafka, the Kafka is an append-only immutable log. So you may think that once the data is in Kafka, you will never be able to delete it. Well, that is possible. It's really possible. But you have also options to delete data from Kafka after a while if it doesn't make sense for you to keep them there anymore. You have what are called topic retention policies, and you can tell Kafka, well, keep the data in Kafka for 6 months, 6 weeks, forever, 2 hours, and is time-based. Or you have the other option, which is saying, keep the data in Kafka until the log arrives to 10 gigabytes, and is size-based. Of course, when you use size-based, you really understand and manage how much the log will take in disk space, but you lose the concept of for how long a certain event, a certain message will be available in Kafka. On the other side, with the time base, you know exactly for how long the message will be in Kafka, but you lose the control over the size of the log or the partition itself. You can also use both to say keep the data in Kafka until it's 6 hours old, or the log raises until 10 gigabytes. You have that option too. So we understood that we have logs that are called topics, we have partitions, and we understood that we can select a partition when we somehow push the data to Kafka. Why is useful to select a partition and how we do that? Well, usually you select a partition with the key component of your message. Usually the key component of the message is hashed, and the result of the hash is used to select a partition, ensuring that all records, all messages having the same key land on the same partition. You can change this behavior. For example, from your producer side, you want to specifically say, I want to send this message to partition 3 or 5, but usually you rely on the default partitioner. You can also, on the other side, send messages to Kafka with null key. In that case, what Kafka does, it assigns a random partition in a round robin fashion to the message. So you will not be able to know which partition is used in that case. Why choosing a partition is useful? Well, let me tell you a story. Let's check this situation out. We have a producer that produces data to a topic with 2 partitions, and then we have a consumer. Let's take a really easy example with only 3 messages. Blue one first, yellow one second, and red one third. When pushing data to Kafka, the blue event, the blue message lands in the partition 0, the yellow event lands in partition 1, and the red event lands in partition 0 again. When reading the data now, we could have, it's not always the case, but we could have that we will read the blue event first, the red event second, and the yellow event third. Why this is happening? It's happening because Kafka, when you start using partitioning, guarantees the correct ordering only per partition. So you need to carefully select partitioning and select where a certain event, a certain message, which partition a certain message goes to, because you will need to understand for which subset of messages you care about the related partitioning. So in the example that we gave before, partitioning the pizza orders per restaurant could be a good choice because you want all the orders of a specific restaurant to be in relative order. But you don't care if you lose the order between Mario's Pizza Restaurant and Luigi's Pizza Restaurant, because those are different realities. So we understood that partitions are good because they allow us to avoid the disk size to log size drama. Partitions are bad because we have to give up on the global ordering once we start using partitions. But still, partitions are good because they allow us to scale out. If before we had one unique log, you can imagine that unique log as being one unique thread that has to push one message after the other. So if you have a lot of producers, still they have to go through this one unique thread pushing data. Now that we have several partitions, those are basically independent threads. Every partition is now one process that has to push data. So we can have a lot more producers start pumping data to Kafka. And on the other side, we can have also a lot more consumers starting reading data from Kafka. And in order to avoid that the same order, the same pizza order, the same message is read twice, what Kafka does, it assigns to the consumer a non-overlapping subset of partitions. So let me tell you how it is. We have 3 partitions, blue, yellow, and red, and 2 consumers. Kafka by default will assign, for example, the blue partition to consumer 1 and the yellow and red to consumer 2. Why is doing that? Because in this case, it ensures that all the messages are read, and it also ensures that none of the messages is read 2 times. And also, if, for example, a consumer somehow dies, consumer 1 goes away, Kafka will detect that, and at a certain point, send also all the blue messages to the consumer still alive. But you don't have to trust me on the word. Let's make again a nice example. Let's go back to our notebook and let's open the partition producer. Let's put it in here. So I'm creating another producer like the one before. And in this case, before producing data, let me create with Kafka admin client a new topic called partitioned. It's Francesco Pizza partitioned with 2 partitions. And since I'm really brave, I have a replication factor of 1 because I don't want any copy. Doesn't matter, just for demo purposes. So let me create this. Now the topic is created. And now since I have 2 partitions, let me create 2 consumers on the other side. So let me create consumer number 1 at the top. And let me register consumer number 1 and it started. And now let me do consumer number 2 at the bottom. Let me close this so it's bigger. Okay, let me start also the consumer number 2. Okay, I have consumer number 1 and consumer number 2. They are both with 0 records. Now let me start sending 2 records. One with key ID equal to 1, one with key ID equal to 2. If everything works as I told you before, I should receive probably a message on the top consumer and a message on the bottom consumer. Let's try this out. Yes, exactly. So I receive Adele's order at the top and Frank order at the bottom. If you wonder what those little flags mean, this means that I'm reading the partition 0 offset 0, and I'm reading the partition 1 offset 0. So I know that Frank Pizza Margherita order arrived on partition 1, and I know that Adele's arrived on partition 0. Now let's try again. So I'm creating other 2 records with the same key with other orders, and if everything goes well, I should receive Mac Pizza Banana order in the same partition as Frank Pizza Margherita, and I should receive Jan Pizza Mushroom order in the same partition as Adele because they share the same key. Let's try this out. Exactly. So Jan arriving on the same partition as Adele with ID equal to 2, and Mac arriving to the same partition as Frank with ID equal to 1. So now let me try even more. As I said before, if a consumer dies, like I want to let the top consumer to die, it's died, it's very red and died, I should receive all the messages now on the second consumer because Kafka will understand that the top consumer died and send all also the other partition to the new consumer. Let's try this out. Exactly. So now we have the second consumer, the bottom consumer, taking not only the data from partition 1, but also from partition 0. So I have the 2 new messages from Joe and Mario landing on the second consumer, the only consumer alive. Everything working so far, as I told you, so you don't have to just blindly listen to me. Let's go back to slides again. Okay, we understood how to push data, how to consume, how to partition and use the partitions brought from a producer and consumer point of view, and how Kafka understand if there are failures in the meantime. But one thing that I told you is that Kafka is a persistent log. And even if my consumer application reads from it, the data itself is not deleted until my retention policy kicks in, or basically until I want it. This makes the data available also to other applications to be read. So if we go back to our pizza idea, I could have my 2 consumers there that could be the 2 pizza guys fighting one against the other to make all the pizzas for all the orders of the restaurant. And they want to consume all the orders, but they don't want to read twice the same order because they don't want to do twice the same pizza. On the other side, I could have the person doing the billing that wants to receive his own copy of the orders because this person has to do the bills. and it wants to read the orders at its own pace without having to conflict with the pizza guys. How can I deal with that with Kafka? Is just by defining the consumers as part of a consumer group. So I define the two existing consumers, the two pizza persons, as part of the same consumer group 1, and then I will have the billing person that will be a new consumer, part of a new consumer group. So it's pizza makers and billing person consumer groups. Now Kafka will see this new consumer part of a new consumer group and will send a dedicated copy of all the partitions. Again, you don't have to trust me. Let's go back to the demo. So if we go back to our original producer and original consumer. So what we saw on the original consumer is that we attach to the topic with, now it's fair to say, we use this group ID called My Pizza Group. This is where you define the consumer group. If you remember well, what we did, we attached to the consumer a little bit late, so we were not able to read the first message, but we were able to read the other messages. Now what we will do, we will create a new consumer as part of a new consumer group. So if you see here, what we are saying is that this new consumer is part of a group ID called My New Pizza Group. I'm a new application. I want to receive another copy of the data. The other change that we do here compared to the original consumer is that we say to Kafka, when I'm attaching, please send me all the data since the beginning of the log. This out of offset reset equal to earliest is telling Kafka, send me everything from the beginning. Now, if we execute this, we should start receiving a copy of all the logs, all the messages from the log, including the first one. If we check in detail, we can see that we receive a copy of both the two orders that were in the original consumers, there we are, but also the first order that was skipped because we were joining with the first consumer later than we produced the first order. Even more now, if we create another order with then ordering pizza with fries, we receive that in both, since those, this one and this one is receiving both consumers because those are part of different applications. So Kafka enables not only one write, one read, but it's multiple writes and multiple reads. The reads can be concurrent, so multiple processes trying to read the same messages one against the other, or could be multiple applications that want both to receive at their own pace the same data set over and over again. Okay, we demonstrate also that. Let's go back to another piece of slides. As of now, we understood a lot of things, how to produce data to Kafka, what Kafka is, how to consume data from Kafka, how to use partitions, how to use consumer groups. All of this, however, was based on the fact that we were basically writing our own code to write data to Kafka or to read data from Kafka. The reality in a lot of applications is that we will not end up in a greenfield situation. We will have to have Kafka being part of an existing ecosystem of data platforms. And in order to connect to those existing data platforms without having to write code, there is a framework called Kafka Connect that allows me to easily read data from existing data sources, for example, Cassandra, Postgres, any JDBC database, Google PubSub, or at the same time, once the data is in Kafka, allows me to easily, with this pre-built framework, distribute data to a lot of data sinks. So do I want to send data to Elasticsearch, to Amazon S3, to Postgres, to any JDBC database, to BigQuery? Depending on what my team needs, I can easily distribute the data to those platforms. Kafka Connect doesn't only do this kind of data movement job, allows also us to basically evolve existing applications. So if we go back to the 10 years ago reality where we had our Python application right into a backend database, we may want to take this to the new world of streaming data, but we don't want to touch the existing Python application because it has been there for like 5 years and nobody complains about that. So we don't have to spend time on it. We can include Kafka in the design by using Kafka Connect and change data capture solutions that will start reading all the changes happening in a database table and start propagating those changes as messages in a Kafka topic. Really, really easy. On the other side, Kafka Connect allows us also to distribute the events. So if we have our Python application or anything pushing data to Kafka topic, and if our, for example, team wants to have the data somewhere else, we can just use Kafka Connect, for example, to distribute events to a JDBC database. Or in particular, if they love Postgres, we can distribute also copy there. Do they want the data in BigQuery because they need to do some more analysis? Kafka Connect, another connector, it's there. And if they want also the data in Amazon S3 because they want a long-term storage, another Kafka Connect connector is there. The beauty of Kafka Connect is that it's driven by only a config file and a single thread. If you are on premises, you will have to manage this single thread by yourself. If you are in the platform like Ivan, we will manage this thread for you. So you only have to push the config file. Again, you don't have to trust me. Let's check it out. Let's go back to our notebook and let's do something like this. Let's go to our list of notebooks and take the Kafka Connect one. Let's close a little bit of other windows. Now we create another producer. And what we will do, we will create another topic. This time we will not send only the information Francesco is ordering a pizza margherita. Together with that information, we will send to Kafka also some information about how the record itself is built. So we have for each record, for each message, we have the key that is made by an integer called ID, and the value itself, it's made by two strings, one called name and one called pizza. So this is the format of our messages. Why are we sending that to Kafka? Because it makes simple for Kafka Connect to basically unpack the message and deliver the value of the message to downstream applications. So we created the schemas, and now we are going to send the schemas and the orders themselves to Kafka. So we are sending 3 messages: Frank ordering a pizza margherita, Dan ordering a pizza with fries, and Jan ordering a pizza with mushrooms, to this new topic containing both the schema of the data and the data itself. Okay, so I told you that Kafka Connect allows us to, for example, easily distribute data once the data is in Kafka. What I will show you now is that I can easily distribute this data to a Postgres database. So if you remember before, I created not only Kafka, but also Postgres database. And because I don't want you to think that I'm saying fake things, I want to show you that I have, let me show you, a database called Global Azure. It has a default DB, public schema, and there are no tables, 0 tables in there. Okay, now let's go back to my Firefox and let's check what I need to say as configuration file in order to make this replica work. I can go to the config, this Kafka Connect setup txt. All I need to tell to Kafka Connect is where to find the data and where to push the data. Let's check together. I need to say where to find the data. So the topic that I want to push to Postgres is called Francesco Pizza Schema. It's the new topic that is just created. How is the value encapsulated in this topic is in a JSON format. Where do I want to send this data to? I want to use a JDBC sync connector. I'm using JDBC to push the data to Postgres. And you can find my Postgres database with this JDBC URL. using this very secure username and password. Please, if the target table doesn't exist until now, please auto-create it. This is the only stuff that I need to tell to Kafka Connect. Let me copy this JSON. Let me go to my Kafka Global Azure connection tab. I can create a new connection here. JDBC sync. Now I can fill all the parameters by hand, or since I have this JSON file, I can copy and paste here and click apply. This will basically parse the JSON file and fill all the parameters for me. So I can create this new connector called Sync Kafka Postgres. It's a JDBC sync connector, and it's taking the JSON value, which is in the JSON that is in every message in my Kafka topic, and send it to Postgres. Which topic? My Francesco Pizza schema. All that, I can now create the new connector. You can do this by code, and in the Jupyter Notebook is there by code. I just wanted to show you the web UI. Now my connector is running. This means that I should now go back to Postgres and check. I should see a table in there. Let's check this out. If we go back to Postgres and it refresh, look, now I have my Francesco Pizza schema table available. If I double click on that, have my 3 rows. So the same 3 orders, Frank ordering pizza margherita, Dan ordering pizza with fries, and Jan ordering pizza with mushrooms, are in Postgres now. Kafka Connect automatically created a table and start populating the data. But still, this process didn't stop. If now I go back to my notebook, and where are we? There we are, and add another order for Giuseppe ordering pizza with pizza Y, I execute this. Now this is in Kafka, and this should be propagated into Postgres. Let's check this out. If I go here and refresh, there we are. We have also the updated record with Giuseppe ordering pizza with Hawaiian pizza. So you can understand the power of this. Kafka Connect allows me to easily connect with just a config file to any existing data source and import data into Kafka topics, or from Kafka to push the data to downstream data sinks. A final slide just to have a global review of whatever I said so far. So we understood a lot of things. We understood how to produce, how to consume data, what Kafka is, the partitions, multiple applications on different consumer groups, and now Kafka Connect. You understood the whole platform in just under 60 minutes. You may be confused because there are a lot of things. If you want to know more, I listed some resources that you may find interesting. The first one is my Twitter handle. You can find me on Twitter. My direct messages are open. And if you have any question regarding this session or Python or Kafka or any of the open source technologies that Ivan offers, just ping me. The second link is actually the notebook that I've been showing you. You have a copy as public repository. So you can take that and do the same actions that I did, and you will have probably the same results if you did them in order. The third link is, if you want to try Kafka and you don't have any data, I create in Python a fake pizza producer code that will produce messages that are creating pizza orders that are a little bit more complex than this one that we just saw, where it had only the name of the person and a single pizza. In that case, you will have multiple pizzas per order and a lot of additional information. The last link is that if you want to try Kafka, but you don't want to manage it yourself, well, check out ivan.io, because it has a lot of good resources for you to basically just click and start a managed instance of Kafka or any of the open source technologies that we offer in a few minutes. And if you go there, you have also $300 of free credit that you can use to start your journey into Kafka. The last bit is Ivan is a Finnish company, but I'm Italian. I'm talking at an Italian conference, and we have a subsidiary here. So if you are interested, we are hiring if you want to work in the basically the data ecosystem together with a lot of coding, well, we are here and we are growing a lot. I hope you will find this interesting. And as I said earlier, you can find me on Twitter or LinkedIn. My messages are open. Just ask me anything you want. Thank you very much, and I hope to talk to you soon, probably in real life. Ciao from Francesco.